to the sky and the sea below. Then down to the ground and rain and snow. I keep it moving away, cause I'm the water cycle. Moving away, cause I'm the water cycle. And water transforms from liquid to gas and rises up into the atmosphere. That's evaporation, a process made possible by energy from the sun, also known as solar radiation. And when there's water vapor in the sky, it forms into liquid water droplets. That's condensation. And when this water falls back down to the earth, that's rain, snow, hail, that's precipitation. The plants have their own type of evaporation through their stomata, which is called transpiration. So collectively, the term used for transpiration plus all other evaporation is evapotranspiration. Two more terms to add to your collection. The movement of water through the air is advection. And speaking of keeping it moving, understand that runoff is water flowing across the land. Rise in the sky from the sea below, then down to the ground is rain and snow. I keep it moving away, cause I'm the water cycle. Moving away, cause I'm the water cycle. Rise to the sky from the sea below, then down to the ground is rain and snow. I keep it moving away, cause I'm the water cycle. Moving away, cause I'm the water cycle.
All right, guys, so there's a new water cycle song. Just so you all know, I am updating our interactive notebook as we go for the water cycle. So as we listen to a song or watch a video together, if I think it's important enough to help you review for whenever we have a test or for the end of the year, or if you just need a little bit more practice on the lesson that we just had, then you're going to be able to refer to your notebook in real time. I'm not going to wait until the end and update it like we did for heat transfer. It is really good to see so many of you here this morning. We're still missing a couple people, so I'm going to send them an invite really quickly. But while I'm sending them an invite, is there anyone who can tell me what it was that we talked about yesterday? What did we talk about yesterday? And you can either comment in the chat or you can raise your hand and I'll call on you. Okay, so we did talk about the water cycle. Excellent job. Let's be more specific. What's something else that we talked about yesterday? Asia.
The code password or the password code.
Okay, and what was our password code yesterday? Do you remember what it was?
No.
No? Oh, man.
I do.
All right, Nellie, what was it?
Evaporation.
Evaporation. So a lot of our conversation yesterday focused on evaporation. Nellie, what else can you remember that we talked about yesterday?
That's the code.
Is that what you were going to say?
Yeah.
Okay. All right, so we did talk about evaporation yesterday. Cullen, do you remember something else that we talked about yesterday? Or did they take yours? Cullen?
We took it.
Oh, okay. Thank you. I'm sorry. I couldn't see my chat while I was sending the email. Thank you for sending that to me in the chat. All right. So we talked about more than just evaporation. The song even talked about it. What drives the whole water cycle? Without this, we don't have a water cycle. What is this that I'm referring to?
Water.
Nope. Raise your hand. But that's not it. What is it? The water cycle can't happen if we don't have this. Of course, water, but it drives it, causes it to move. Helen, were you going to say something? I interrupted you. I'm sorry.
Condensation.
No, that's part of the water cycle, but what causes the water cycle to start? It gives it the fuel to make it go. And when we think about fuel, think about
The sun.
energy to get the sun. So without the sun, Nellie, were you going to say that? All right. So without the sun, absolutely, we cannot have the water cycle. It is extremely important that you guys remember that the sun drives pretty much every biotic or living cycle here on Earth. When we start talking about ecosystems and food chains, we're going to see that without the sun, we don't have plants, so we don't have producers. So then the consumers don't have any producers to eat. And the only organism that's capable of transferring energy from the sun, thermal energy, into energy that we can use are plants. But plants don't have energy if the sun's not shining. So the sun is pretty much our energy battery cell. Without the sun, without energy from the sun, everything stops.
You make that too confusing.
Okay, so without energy from the sun, nothing can go. So it's like, the charger for your phone. Once that energy has been depleted, then you have no more energy unless you plug it back into the charger. So the sun is like our charger. It is our fuel to keep the water cycle going, to keep the food chains going, to keep really everything going. So very important. Without that big star that we rotate around, everything ceases to exist. So today, really quickly before I get started, there are some of you that have not submitted a presentation yet. This is extremely the most important thing for you to do today. Jacaden, Jaquel, and Samantha, your presentation has to be submitted today on Flipgrid, which is last Friday's assignment, or it's going to be a 0. If you have a 0 as a test grade, it is impossible just about for you to pass this quarter.
It's not letting me submit it.
Okay, so stay after on science today, and I'll get you to share your screen, and we'll troubleshoot, okay? Also, I think we're good on the test for you all. I'm going to refresh this because I did add a water cycle video because I realized that yesterday, even though we had a lot of fun, a lot of the students from my class had a hard time remembering what we talked about and how each step plays with the other one or into the other one, and how the sun is the driving force behind the water cycle. So I added a water cycle recap video that we are going to watch together. It's about 6 minutes long. I'm going to try to scoochie my thing up here so you guys can see a little better. Go that way with it. All right. So here we go. Are y'all good? Everybody can see okay? All right, here we go.
Yes, ma'am.
Thank you.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle, so simple even small children understand the basics. Yet so complex, the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes, in rivers and streams, in reservoirs and watersheds, in wetlands, in the soil, in and on plants and trees rooted in the soil, and beneath the soil, in water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants, and trees.
Like you might imagine someone in the game of football intercepting a pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscape, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downwards so it will move
Through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than in the form of a liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw off groundwater.
And plants pull that water up through their stems into their leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee-worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air. Mixed with smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier, until they are so heavy they fall again.
All right, guys, so we're going to stop right there because we are going to try to take the steps of the water cycle one chunk at a time today. So we're really going to focus on the process of transpiration and the process that happens simultaneously with that. So the first thing that we're going to do is we are going to look at this picture here, and we're going to kind of recap what we've already learned together yesterday. So yesterday we talked about the energy from the sun, and we kind of recapped that earlier. What happens with that energy from the sun? Comment in the chat, or you can raise your hand. All right. Okay, so what, okay, yes, so the sun does give energy. Let me back up a little bit so you guys can see the whole picture. All right, so the sun does give energy. And we also knew that the sun radiates energy. See that in the chat, the sun radiates thermal energy. So here on the sun, we're gonna write thermal, ooh, maybe I need to pick another pen. I don't like that. Come on. Okay. Oh, part of my flower die. There we go. All right. Let me use a pencil. All right. So, ew, gross. Make it smaller. All right, last time. We have thermal energy. Make it even smaller. Radiates from the sun. So without the radiation from the sun, we don't have a water cycle period. So we have to have some of the thermal energy from the sun radiating, which are these red waves. So remember, it radiates in electromagnetic waves down from the sun. So we have thermal energy from the sun radiating to the oceans and the trees and the plants and the grass down below. So what did we learn yesterday about the oceans? Does anybody remember what we learned yesterday about the oceans? In Genesis, I see your hand raised, but it may have been for something earlier. Do you want to share?
Yeah.
Okay.
So the sun uses energy to evaporate the water in the ocean, I guess.
Yes. So the sun's thermal energy causes water in the oceans to evaporate. We talked about that yesterday. Absolutely. But what did you guys remember about the oceans? How much of our water that's on the earth is stored in the oceans? Who remembers? It's a lot. Nellie?
About 75%.
Well, 75% of the earth is water, but out of that 75% of the earth that's water, how much of the water is stored in oceans?
2/3.
No. Genesis?
The sun, not the sun, but the water used to be from the dinosaurs.
No, but my question was how much of the water that's on the surface of the earth is stored in oceans? Because we talked about yesterday how evaporation happens, and most of the water that's evaporated every day comes from the oceans because the oceans supply a big amount of the water. I had a student comment 89% in the chat, and it's even more than that.
97%.
Yes, Genesis. 97% of the Earth's water is stored in the oceans. That means that there's only 3% that is stored in rivers and streams and puddles and lakes and ponds and the glaciers up near the Arctic and down near Antarctica. So yes, 97%. almost all of Earth's water is stored in the oceans. So if you ever get asked, where does most evaporation happen? Most evaporation happens in the oceans. All right? So, yes, going back to what Genesis said, when the thermal energy from the sun radiates on the oceans and on the streams and the ponds and the puddles and whatever else is around, it causes those water molecules to begin to vibrate more and more and bounce around even more and more crazy until they change from a liquid to a gas. They change from liquid water to water vapor, which is where we get the word evaporation. Remember, it has the word vapor in it. Evaporation happens. When these molecules begin to heat up, evaporation happens. And remember, the water molecules continue to evaporate until they rise higher and higher and higher and higher into the atmosphere and form what, Jamari?
Oh, I had a question about the ocean.
Okay, yeah, go ahead, ask your question about the ocean.
So, so do you think that in the ocean there could have been more than 97% of the water? There could have been more.
Do I think there could be more of 97% of Earth's water in the ocean?
Yeah, or like it's been gone for it's been like going away for like years and years and years.
I think 97% is a pretty accurate number for right now. Just out of all the water that's on Earth, it's just saying that 97% is in the oceans. It could be increasing because of global warming, or it could be decreasing because of droughts. I honestly don't know. I just go by the information that I've researched, and from what I know, about 97% of the Earth, or 97% of the water on Earth, is stored in the oceans. So a large majority, almost all of the water on Earth is in the oceans. But then, of course, you guys know we have rivers and streams and ponds and lakes that we like to go to, have fun at. So there's definitely water sources other places. But when you think of how big and vast and deep and wide oceans are, it's easy to understand how so much more of the water is in the oceans. Great statement there. So what we were talking about, guys, is that how when the water molecules begin to heat up on the surface of the oceans, they begin to change from liquid water to water vapor and evaporate and rise into the atmosphere until they get high enough in the atmosphere that they start to cool down. And remember, when things cool down, they condense, they clump together. And what does that form, Nellie?
That forms like rain.
Not quite. We're skipping a step.
No, clouds.
Yes, so we have clouds. Now, on Monday, we're going to talk more about the process of condensation and how exactly it happens. But I do want you to know that when water evaporates, it does condense to form our clouds. So I'm going to go ahead and have that there and label it. But know that we're going to really focus on condensation on Monday. Now, we know that thermal energy from the sun radiates down, warms up water molecules, and causes them to evaporate. Causes them to evaporate from the streams. And it also causes them to evaporate from ponds or puddles as well. All right. Now here is the one that we have not learned about. There's also a process that is occurring simultaneously, that means at the same time, as evaporation. And if you were paying really close attention to when I accidentally skipped the slide and told you about the next thing, or if you're paying close attention in the video, then you know what the process is. Is anybody paying close enough attention to catch the word? It's a brand new word I'm sure that you guys have not heard before. Nellie, did you hear the word?
Yeah, but I forgot it.
Okay, So the process that occurs at the same time as evaporation is, make sure, transpiration. Now, Nellie, I see in the comments that you have a question. Do you still have a question?
Yes.
Okay, what is it?
What about the water you get from your fridge and like the ice you have at home and stuff?
Well, we're just talking about the water cycle that happens naturally in nature outdoors. Now, if you leave a cup of water outside, then yes, it's going to evaporate. Water evaporates even here in the classroom and condensates. Like I've got condensation on my cup, which is a natural process. But right now we're focusing on the process of outside and how it impacts our weather systems outside. Okay? Does that make sense, Nellie? Nellie, does that make sense? Okay. All right. So we're just focusing on how the water cycle happens outside right now. But yes, we have condensation and evaporation happening in our rooms where we're at as well. But right now we're just focusing on what it looks like outside in the natural world in nature. So the word that we're focusing on today is transpiration. Transpiration happens at the same time as evaporation. And transpiration, actually I'm gonna let you guys try to figure it out. So when we are outside in the sun and the sun is glaring down on us and it's super hot, we're like, whew, what does our body do when it's outside in the sun and it's absorbing all that radiated energy from the sun, that radiated thermal energy? What does our body do? Yes, I got it in the chat. All right, got 2 people in the chat. They already know. What does our body do when we get hot in the sun? I keep almost saying it. Tamara, what happens? Yes, Lee. Yes, Genesis. Yes, Boomy.
Transition.
No, what happens to our bodies when we get hot?
Yeah.
Yes, Asia. Yes, Laylan. Keep thinking on it, Samara. What does our bodies do when we get hot out in the sun? Jamari?
What it does, it heats up from the radiation from the sun.
So what does our body do when it heats up from the radiation from the sun?
We sweat and
Yes. So the sun causes us to get hot, and the effect, what happens after we get hot in the sun, is that we sweat. Does anybody know the scientific term for sweat? Starts with a P. Nellie?
Precipitation.
Close. It's very, very, very close. Anybody else want to give it a shot? Genesis, do you know what it's called? It sounds a lot like that. What's the scientific term for sweat?
Transportation?
No, starts with a P. Nellie knows what it is, but okay, Nellie, you want to try it again?
Perversion. Wait, what? Perversion.
It's a perspiration. So when we sweat, the scientific term for human sweating is perspiration, which is why some of your deodorants might say like an antiperspirant. It keeps your body from perspirating or sweating. So if you listen to perspiration and then you see the term transpiration, and we're talking about the plants, what do you think transpiration might be? Cullen?
I can't say the word, but I know what it is. I just can't say it.
Perspiration?
Oh, yeah? Yes.
Okay, so but what do you think transpiration might mean? If perspiration is human sweat, what is transpiration?
Plant sweat?
Yeah, Transpiration is basically plant sweat. Excellent job. So transpiration is when water travels from the plant's roots through the plant and out through its leaves. And the plants are sweating. So they're getting little bitty water droplets that are on their leaves, and water vapor is being released from its leaves. And that water vapor too is also evaporating, evapotranspiration. It is evaporating to also form the clouds. Now keep in mind, there's lots of plants down here. The grass, every blade of grass is covered in stomata, which are like pores, just like your skin is covered in pores. Like if you look really closely, you can see the holes on your skin because it's covered in pores. Leaves are the same way, and blades of grass are the same way. They have little bitty tiny holes, and of course, because they're so much smaller, you need like a magnifying glass, more than a magnifying glass, microscope to see the stomata, the pores on the plant. But those pores also release water. So transpiration is plants releasing water vapor into the atmosphere to later condense into clouds. And we also have evaporation from bodies of accumulated water. Now, I've got lots of people's hands raised, so if you want to add something or ask a question, this is your time.
I have a
Yes, Nellie?
Do trees have pores? Wait, no. And the thing you said sounded like you were talking Italian or French.
Oh. All right. Well, raise your hand again if you got a question. But yes, trees do have pores because remember the leaves, trees have leaves, and leaves are covered in stomata, just like your skin is covered in pores. All right, Genesis?
What was the question again?
I just saw that your hand was raised, so I wanted to make sure that I gave you an opportunity to say what you needed to say. If you had a question or had a comment, or if you just forgot it was raised, I can go ahead and lower it. I just wanted to make sure I wasn't going too fast for you. Huh?
I'm good.
Okay. Cullen?
What's BD code?
I don't
Are
know.
we coming up to that?
We're coming up to it. All right. Samara?
Do people help make clouds?
Do what?
Since when people go in the ocean, they're mostly carrying water on their bodies.
Yes, but that's not a process of condensation with people being in the ocean.
But there's little water droplets on them when they go in the ocean.
Yeah, so if the water evaporates from them, then yes, the water that is on them would be contributed to the water cycle. But let's not get too confused, like adding people into the equation right now. Okay?
Okay.
So yes, if water evaporated off of their bodies, then absolutely, they would contribute to the water cycle. All right, Genesis, did you think of something? Or did you forget to put your hand down?
So when I was little, I was wondering why is the sun following me?
I'm sorry?
I was little, I was wondering why is the sun following me?
Oh, all righty. Well, it's a good question. Good wonder. Maybe you can research and find the answer to that. All right, but let's go ahead. We are going to bounce back to, I'm going to save this so we can refer to this later because we're going to add some to it after we talk about condensation.
Ms. Hernandez, I have a question.
Okay. Go ahead.
So when you're in like your house or something, and then there's a little bit of dots on your water bottle because you don't drink it fast enough. What are those?
It's condensation. And we'll talk
But
more.
why is it condensation if there's no heat going onto it?
Well, there is a difference of heat because your drink is colder than the air that it is in the room. So, but we will talk about that. But right now, I just want to stay outside with our thinking of the water cycle. We will bring that process inside next week, okay? And we'll discover how these things happen in the house. Okay? All right, so lastly, here's another short little video that kind of recaps what's happening in the process of transpiration. And if you think you have a guess for what our code word may be, you can go ahead and comment in the chat, and I will let you know. If you would like to leave early, you're free to do that once I tell you if you're correct.
All right, welcome to the next step in the water cycle, transpiration. Humans sweat, and whenever we sweat, what's happening is water comes out through our pores. We have to consume water, obviously, to make sure we stay hydrated. The plants do the same thing. Through transpiration, plants through little things called stomata, which you can see right here, exit water through there and enter the atmosphere to condensate again and come down as precipitation. And this is all part of the water cycle.
All right. It is time for the code word. If I call your name, you have the word correct and you may go, but please make sure that you are spelling correctly. Cullen, Maeve, Nellie, make sure you're spelling correctly. Yes, Mackenzie, you are correct. So for those of you who did not take, if you did not take an opportunity to guess the code word, your code word for today is transpiration. So go ahead and take a screenshot of the code word so that you can enter it into your assignment today. Please make sure that you note that all letters are lowercase. So if you want it to grade it automatically for you, then make sure you enter in all of your letters lowercase, and please make sure you spell correctly, and then you are free to go once you've taken the screenshot if you don't have any questions. But I would like to see those of you who are having trouble with the Flipgrid.